Good morning, everyone. Um, Today I'm just going to go very quickly and very briefly on the topic of finding tangent equations, or the equation of tangent lines. This is exercise 20A. You'll find it on the portal as well, and for the PowerPoint that is. And I'm going to provide a quiz during session 1. I want you to complete it and submit it before lunchtime for me, just so I know that you're doing okay. Okay? I should be back tomorrow, just letting you know. It's just today is very short after speaking to you guys on video. Anyways, let's begin. So, tangent equations, what is this? Remember tangent equations, I told you that it's actually just straight lines that touch the curve at a particular point. Okay? You got to keep that in mind. It's just basically a straight line that touches a curve at a particular point. Now, remember the equation of a straight line is y equals mx plus c. This is the equation of your tangent line. Okay, it's the equation of a straight line. And if you remember as well, I wanted to touch was highlighter. I want you to remember that m is what you've been doing this whole time. When you find a derivative, you're actually finding m this whole time. You're trying to find the gradient of this tangent line. Okay? Then, to find out the m, which you know is by differentiating the curve. So, let's have a think about this. Let's say I gave you a curve that was a quadratic. Okay, so this is your quadratic. It's y equals x squared. That's a quadratic function. Okay, notice my color coding. Curve is your red, straight line is your tangent. Let's say x equals 2, right? At x equals 2, I've got this point. When x equals 2, then obviously y equals 4. That's just because the quadratics. Yeah, square of 2 is 4. So, square of 2 gives you 4. Okay? Next thing is, well, at this point, you've also got a tangent line. You've got this straight line that touches. You see, this touches that point at x equals 2. At this point, at that very point right there, it has a tangent line. Okay? And this is what I'm saying. When you're differentiating, you're finding how steep, or the gradient of this line. What is this line? This line is your tangent line. Is your tangent equation. It has y equals mx plus c. In order to find out the equation of this, you can find out m. Okay, you can find out m just by differentiating. So if I found out m right now, it's just by differentiating the curve, okay, y equals x squared, differentiating the curve, and notice that the straight line equation also cuts the y-axis, which is your c value, and that's your y-intercept of your straight line. Okay, so let's find out m. M is the differentiating, or is differentiating y equals x squared. So, if you think about it, derivative of y equals x squared, which you all know by using power rule, m, which is your gradient, is finding the derivative. It's actually equal to 2x. But remember, this is only your gradient function. This tells you all the gradients around the curve, doesn't tell you the gradient at this particular point. Okay, so then you say, alright, well, whoops. Let me just write that down again. I can't touch it. Wait. Red. Alright. So, whoa. Wait. Sorry, guys. Really trouble doing this. Okay, so we know that at x equals to 2, okay, at x equals to 2, you will have a gradient at 2x. So m equals to 2 times that x equals 2, that gives you 4. What does that tell me? That just tells me that the gradient at this point, so the gradients, see how I'm drawing rise over run, this is rise, and this is run, rise, and run. It just tells me I'm rising by 4, and I'm running across by 1, okay, because the gradient is 4. So this just tells me this straight line is 4x, and I don't know what c is. But I can find that out because on that line I've got the point 24. Okay, so that's the theory behind it, and really, that's what you're really doing in this chapter, or this exercise 20A. It's just basic year 9 maths again, but you got to understand that differentiating helps you find the gradient of a tangent line. Simple as that. Okay, let's move into some other year 9 revision here. Year 9 revision, a few things you would have learnt. You remember straight lines, general equations, y equals mx plus c. Next one is normal or perpendicular lines. Okay, now in the year 11 syllabus we call it the normal lines. Okay, basically it just means if you had two straight lines, so let's say this is your axes, okay, and you've got a straight line that looks like this, okay, then let's say that's y equals m1x plus c, so I'm just saying m1, which is the first gradient. Then you got another straight line that is perpendicular to it, which means it makes a 90-degree angle. This is y equals m2x plus c. Then if you remember that one of the things we learned in year 9 maths is that if you multiply the gradient of the first one times the gradient of the second one, it should equal to -1. That is then perpendicular. Okay? And the last thing you learn is parallel lines means both straight lines have the same gradient. What does that mean? Well, if you have two lines that have the same gradient, then it just means m1 x plus c and y equals m2 x plus c. It just means that m1 and m2 are the same, but not necessarily c, hence why they're parallel. Okay, same steepness, different y-intercept. That's basic year 9 math revision again. Okay, so just say m1 equals m2, but not necessarily have the same y-intercept. Okay, that's all the concepts that you really need. Let's do a few examples just to get you really understanding how to solve problems. Okay, so let's do one problem here. Example 1, it says find the equation of the tangent to the curve y equals x cubed minus 2x squared at the point 1, -1. Now I want you to focus on a few key points here. So they're saying, alright, I've got y equals x cubed. That's my curve. Okay, that's my curve at the point 1, -1. This is already telling me a few things. This is already telling me, okay, so I've got a curve y equals to x cubed minus 2x squared. This is telling me that x equals 1 and y equals to -1. So that's where it's crossing. So imagine the cubic graph looks like this, then at x equals 1, so this is where x equals 1, I've got a tangent line. Okay, that's all it means. And at this point, it's 1, -1. That's what it's telling me. Okay? So what they want you to find is to find the equation of the tangent and then hence find the equation of the normal. Alright? So let's do this. I'm going to do this on the slide over here to find out tangent equation. So tangent equation. Well, we know the tangent equation follows y equals mx plus c. We know as well that we can find out m. Okay, we can find out m by simply differentiating the problem here. Whoops, that wasn't meant to happen. So we can find out m by differentiating. This is really troublesome, but you know, so many color changes. Okay, blue. So you can find out m by differentiating the curve. Now the curve is x cubed minus 2x squared. So dy dx will give me 3x squared minus 2x. So this will technically tell me my gradient. Okay, but remember, where is this? This is only a gradient function. Okay, this is only a gradient function. So in order to find out the gradient, you got to find it at that point, which is at x equals to 1. Okay, at x equals to 1, my derivative, which is my gradient, is equal to 1 squared minus 2 times 1, which actually equals to what? 3 minus 2, which is 1. So that just tells me m is 1. So far, my tangent equation, I know this. M equals 1. So I've got 1x plus c. Okay, so that's really right here, right over here is year 11 maths. But right over here, this is going to be year 9 maths. I've got my gradient, so I know m equals to 1. And I know that I've got a point 1, negative 1. So how do you find your y-intercept? Well, just sub these points in, because you know this is your x, and you know this is your y. So that means negative 1 equals to 1 times 1 plus c. Because remember, the straight point or straight line also crosses at 1, negative 1. That's why you can sub it in. Okay, and you can find out c. So this tells me that c, 1 plus c, negative 1, so c actually equals to negative 2. So what's the equation of my tangent line? It's y equals to 1x minus 2. That is the equation of my tangent line. Okay. Now similarly, you're going to do exactly the same for the normal. Now if you want to find out the normal, it's the same concept here. Okay, it's the same concept. To find out the normal, first you've got to find out the gradient. Now you know that the rule was m1 times m2 has to equal to negative 1. Well, you just found m1. m1 was over here. This is m1. Okay, m1 was your gradient, okay, from your tangent. You want to find a normal which is perpendicular to it. So you know that, alright, well, 1 times m2 will give you negative 1. So that means m2 equals negative 1. So I just found out the gradient, without doing the derivative or anything. I found the gradient of my normal line. So remember, this is my normal line, y equals m2x plus c. I just found out it's negative 1. So this tells me it's y equals to negative 1 x plus c. Same thing again. Well, how do I find out c? I need to sub in a point, but remember this curve, okay, this curve, which I'm going to color in another color over here and try to lessen the confusion here. Remember, if it's a cubic at 1, negative 1, I've got two lines. I've got, whoops, at 1, negative 1, I've got two lines. And these two lines are my straight lines where one is a tangent. So this is a tangent, and then I've got a normal, okay? So that normal also crosses 1, negative 1. So it is possible to sub 1, negative 1 into the equation. So if I do that now, if I sub 1, negative 1 into the equation, you've got now negative 1 equals to negative 1 times 1 plus c. Solving for c, in this case, c will equal to 0. Therefore, we know that the equation is y is equal to negative 1x plus 0, which is just negative 1x. So this is my normal. So that's the equation of my normal, and over here is the equation of my tangent line at that point at x equals 1. Okay, I'm hoping this sort of clarifies a few things. So you notice on my left and right hand side, there's just year 9 maths there. The only part that you have to do was derivatives, which is understanding it's finding the gradient of your tangent. Simple as that. Okay. Last example, before I stop talking, it's starting to ache. So example 2. Find the equation of the tangent to the curve with equation y equals 3x cubed minus 4x squared plus 2x minus 10. So notice this is my curve. This is my curve at the point of intersection with the y-axis. Now that sounds very difficult because they haven't given you a point, but really intersection with the y-axis just means y-intercept. That's all it means. So I'm really just trying to find out the equation of my tangent, which is y equals mx plus c at x0, because I know, actually it's not x0, it's y-intercept is when x is 0, my bad, at 0, y, because at the y-intercept, x equals to 0. Okay, that's all that they're really telling you so far. So let's find out the derivative here. Or if you want to find out the y-intercept, we know that y-intercept is when x equals 0. So if x equals 0, y will equal to what? So 3 times 0 cubed minus 4 times 0 squared plus 2 times 0 minus 10, which we all know is equal to negative 10. So that just tells me when x is 0, y is negative 10. So I've got my point. Okay? The only extra thing I need now is to find out m. So how do I find out m? Well, m, it can be found by finding the derivative of the curve. So if I found the derivative of the curve, so dy dx, this should give me m, which derivative of the curve, which now is what? 9x squared minus 8x plus 2. So I'm just deriving the curve right up here. So this is your curve, I'm just deriving it. Okay? That's my gradient function, but I want to know the gradient at a certain point. And which point is that? It's when x equals 0. That will tell me what my gradient is at that point. So at x equals to 0, what is my gradient? Well, my gradient would then be m equals to 9 times 0 squared minus 8 times 0 plus 2, which equals to 2. That's what it's told me. Okay, so it's told me m equals to 2. That's what it's told me. Okay? Now that I've done that, well, so far, all I found is m. And I've got y equals to mx plus c. So I now know it's y equals 2x plus c. How do you find out c? Well, I've got these coordinates over here. They already told me, or I already solved, that the coordinates, when x is 0, y is negative 10. That's where the straight line or the tangent intersects. Okay? So that means, alright, well, at that point, okay, at the point of intersection of the y-axis, wait, let me just read that again. Find the equation of the tangent to the curve with equation dA at the point of the, at the point of the y-axis intercept. So at x equals to 0, y equals negative 10, they want you to find the tangent at that point. So the point is at 0, negative 10, this is my x, and this is my y. Okay? So all I'm doing... Okay. At x equals 0 and y equals 10, negative 10. So subbing it in, y is negative 10, 2 times 0 plus c. Therefore, c must equal to negative 10. So what's my equation? The equation of my straight line must then be y equals to 2x times 10. Simple as that. Okay, so hopefully this sort of helps you to answer the questions I'm going to give you next, which I'll do now. So questions to do, I want you to do exercise 20A, questions 1, 5, 7, and 8. Okay, those are just for starters. Then after you finished it, I want you to jump, or you can jump onto Edmodo, and you'll have a 5-question quiz. Okay, so do my questions, have it submitted by lunchtime. I'll put a time limit up until lunchtime. Okay, so make sure you do it, just so it helps me understand how you're doing. But notice, I will be online on session 1 on Edmodo, so if you've got questions, just ask. After session 1, I'm going to go rest my cheeks. It's so sore right now. But yeah, so post the questions in the small group section, and I'll try to answer and make as many videos as I can or as I need to. Okay? Yeah, good luck.